For number 17, it's asking us to find the x-intercepts. So we've already, again, we keep learning two different methods of understanding what an x-intercept is. One, it's where a graph hits the x-axis. Or two, it's also the point where y is equal to 0. So I always, since we're doing algebra, I like thinking about the algebraic definition of where it's y is equal to 0, since that one is more useful to us a lot of times. So basically, when I want to find the x-intercept for this given equation here, I need to just think of what is the value of x when y is equal to 0. So a couple ways we can solve this quadratic formula, it's completing the square, but looking at the problems, the easiest method is almost always by factoring. So let's go ahead and try factoring this out. So remember, that's 3 terms. I can set up something times something. And now let's guess and check this. So let's figure out what multiplies to the front. What multiplies to 5x squared? And I know the only things that multiply to 5x squared are 5x times x. Then we look at the back, what multiplies to negative 12? There's a lot of things, might be 3 and 4, 6 and 2, 12 and 1. So you can play around with this, but I think I'm going to try 4 and 3 or 3 and 4. Let's try 3 and 4. I have a feeling, no, maybe not. Let's try, oh wait, 4 and 3. I was right the first time. 4 and 3. So the order does make a difference. If it doesn't work, switch. And I want it to be negative, so I know 1's going to be negative, and I'm going to make this one plus, this one minus. And remember, once you factor it, don't just pretend it's true. You always have to check, and the way I check is the inside and the outside. It has to add up to 11. So inside I have minus 4x. Outside I have 15x. And if I add those together, that gives me 11x, which is the middle term that we can see right here. So since those match up, then I know now that this is the correct factorization. So now we can solve it the rest by factoring using the zero product property, which says I can just split them up to 5x minus 4 equals 0, or x plus 3 equals 0. And let's go ahead and solve this. So if I subtract 3 here, we get minus 3. Here, if I add 4 and then divide by 5, I get x is 4/5. So our two solutions are 4/5 and negative 3, which is C. For number 18, it's another system, but this one's not a linear system, so we can't solve this by elimination or any of those methods we learned. The only way we can check to see if something's a solution in this case is just to actually plug in those values of x and y and see and make sure that it works. So remember, if it's a solution, it works when you plug it in. It gives us a true statement, and it has to work for both. So let's just go one by one until we find the one that works. So let's try this one, negative 3 and 3 for y. So I'll plug it into the first one, and let's see what we get. So I'm going to get 3 times x, which the first one we're checking is minus 3, minus 9 times y, which we see again is positive 3. So I'm going to get a positive 3 here. And it should be less than negative 7 if it's true. So let's find out. I get negative 9 minus 27 less than negative 7, which is negative 36 less than negative 7. So yeah, this is definitely true. Definitely true. So now we got to check the second one though, because we got to make sure if it's going to be a solution, it has to be a solution to both. So now let's plug it into the second one. That's 3 times negative 3 again, plus 2 times 3. And I want this to be bigger than 6. But let's see what happens. I get minus 9 plus 6 is greater than 6, which tells me that negative 3 is greater than 6. Oh, so it did not work. Negative 3 is less than 6. So we can eliminate A because it's only a solution to one. It needs to be a solution to both to be the system's solution. So let's try B now. I want to plug in negative 1, negative 2. So if I try this one out, I'll do this in a different color. Let's see, let's put down in here on the bottom. So I'm going to be 3 times x, which is minus 1, minus 9 times negative 2 is less than negative 7. And I get minus 3 plus 18 is less than negative 7. And I can see that this is going to be 15, which a positive number is never less than a negative, so this is not true either. So we'll cross out B. Let's move on to C. So if I try 9 and 3 now, I'm going to get 3 times 9 minus 9 times 3. Want this to be less than negative 7. Oops. 7, not 3. Negative 7. Where's my... And let's see, I get 27 minus 27 is less than negative 7, which is 0. And 0 is not less than negative 7, so it's not C, so it must be D. But you can probably do that by elimination, but I'm going to actually work it out just so we can just double check it. Doesn't, especially on a test situation, if you have the time, might as well. Don't just rely on elimination alone. So for number 5, 3, I'm going to get 3 times 5 minus 9 times 3 is less than negative 7. And so what do I get here is going to be 15 minus 27 is less than negative 7, which is going to be negative, let's see, if they're opposite signs I can subtract, so I get 2, 1, and keep the sign of the bigger numbers, negative 12, which is less than negative 7. Now we got to just double check the second one. So if I plug it in there, I get 3 times 5 plus 2 times 3 is greater than 6. And let's see, we're going to get 15 plus 6 is greater than 6, and definitely 21 is definitely greater than 6. So it works for both. That is all, as we found out earlier, is going to be my solution. For 19, there's 2 parts to this. They both have to do with complex numbers. So first, we have to know how to subtract them, which really is just like combining like terms. No biggie there. Then after we subtract them, whatever we get afterwards, then we have to be able to graph it. And you'll see that's not very difficult either. So in order to subtract this, we need to combine our like terms. So first, let's distribute this minus sign. That's probably the easiest way. So remember, it just means add the opposite. So let's add the opposites of these. That's going to be minus 5, minus 6. And if I combine like terms, let's do the real parts first. Negative 1 plus negative 5 is negative 6. And here I get 2i plus negative 6i is minus 4i. So now that we have our answer to that, now we can figure out the graph. And so here's our real part. Here's our imaginary part. And if you remember, on the axes, it has it labeled. The x-axis is now our real axis. Here, this is our imaginary axis. So we just graph it the same way. So to the left 6 is minus 6. So that's going to be 1, 2, 3, 4, 5, 6 to the left on the real axis. Then down 4, negative 1, 2, 3, 4 for the imaginary part. And we see the point there is A. So our answer is going to be point A. So this is the type of problem that we've seen most recently on our last set of notes. And that's solving these log equations. And so if you remember, to cancel out a log, we have to exponentiate or turn it into an exponent. However, we can't do that unless we have only one log on both sides. So the right side, that's okay. So on the left side though, I have 2 logs here. I can't just cancel them both out. We have to combine it together into one log only. But we have a way of doing that. We can combine them by condensing it using multiplication. We know that addition condenses to multiplication. Condenses to multiplication. So let's go ahead and do that first. I'm going to condense this together by, remember when we condense, we write the log only once. Then I have x times x plus 2. And on the other side, I just keep it the same. Log base 2 of 15. Now that I see a log on both sides, well, I can just cancel them out since they're both logs. Or I can do a big 2 to cancel them out, but we'll just cancel it. And I have x times x plus 2 is equal to 15. We can distribute this. X squared plus 2x is equal to 15. And now we see, oh, okay, it's one of these where we have a quadratic. We have the x squared term. And recall from our example in your assignment that we can solve this by factoring the easiest. So let's go ahead and solve by factoring, and to do that we need this equal to 0. So we'll subtract 15 to cancel it out. and subtract 15 on the other side. And so I'm left with x squared plus 2x minus 15 is equal to 0. And we can solve this by factoring. So let's set up our two factors. Let's see, I know to multiply to the front, which is x squared, it has to be x times x. To multiply to 15, I'm going to guess it's 5 times 3. And I know one's going to be negative, and since I want them to add together to a positive, the bigger number is probably positive, and the smaller number is negative. But always double check. Don't just go on assuming that's the answer. Here I have the inside is 5x. Outside I have minus 3x. And so yeah, that's 2x. So that is correct because I have a 2x in the middle. And so now we can go on. I have x plus 5 is equal to 0, and x minus 3 is equal to 0. Using our zero product property says I can split those up. And now we can solve. And so my answers are x equals negative 5 and x equals positive 3. Now we have two solutions, but if we look at our answers here, there's only one for each. And we see one of our answers. One of them's 3. The other one's not there. But why isn't negative 5 one of the answers? Well, let's refer back to, remember, this line right here. It says, be sure to check for extraneous solutions. So if I want to check for that, what happens if I try plugging in x is negative 5? Well, I can't take a log of a negative number. It doesn't work. We can't do that. It doesn't exist. So we cross that one out, and so my only remaining solution is 3. So our answer is A.